So we're going to solve optimization problem number 1. But before that, let's see the summary of what we are going to do in the optimization problem. So the first thing to do is the optimization problem. We are going to focus on optimization problems and see how to solve those problems. And then we will develop a model, and with the model we'll find the optimum solution. And this optimum solution will be obtained at the corner points. We're going to look at that particular corner point that will give us the optimum solution. This is exactly the same as what we did with the linear programming. And so at this time, we are going to use a solver. And once we find optimum solution, we are going to evaluate the solution itself. So there are common features of the optimization problem which you're going to meet with as we are solving a number of problems. And the most important thing, or the first thing, is to find the objective function. And so we have 3 types of objective functions. One is to maximize, and so we're going to maximize profit. And then we will minimize costs or expenses. And finally, we are going to look for a particular value as our objective function. In this case, we are going to look at the inputs, because the objective function will be subject to the resources available. And then we will have decision variables, or the changing variables. How much are we going to produce of a particular product for us to maximize, minimize, or to get a particular value. And we are going to have limits, and also we are going to see the set cell, set objective, or the set cell, and that will be part of the optimization model. So let's look at problem number 1. And this problem says, find the product mix that maximizes profit subject to resource and non-negativity constraints. So here we have 2 products. We have product X, and also we have product Y. And so we want to produce this product mix and make profit. Then we know the per unit profit of X is 182. So if you produce a unit of X, then the profit will be 182. And per unit profit of Y is 139. And then we are going to have a number of inputs. We have labor hours, we have chip sets, and then we have electronic components. These are the inputs which we need to produce X and Y. So for X, we will require a number of labor hours to produce 1 unit. And in this case, we will require 6 labor hours to produce a unit of X. And also, we will require 9 labor hours to produce a unit of Y. However, we are limited with the number of labor hours. We have only 7,000 labor hours, and so we can utilize 7,000 or less, but not more than 7,000 labor hours. So let's see the chipsets. And so this is the second input. Now we will require 1 chipset to produce a unit of X, and also we will require 1 of the chipsets to produce a unit of Y. However, we have only 1,000 chipsets. These are the inputs available. And so in this case, because we have no more than 1,000, we can utilize all of them to produce X and Y, or we can utilize less than 1,000. And finally, we have this input, which is electronic components. We have 14,000 of this input. And for us to produce X, we are going to utilize 15 of this input. And also, we will require 10 to produce a unit of Y. And so we can vary X and Y as long as we can utilize this input not more than 14,000. We can use all of this input and maximize our profit, but we can utilize less than this, but not more than this. Now here we are told to indicate the non-negativity constraints, meaning that we cannot produce minus of X or minus of Y. So that's why we have that condition here, and it says X should be greater or equal to 0, same as Y should be greater or equal to 0. That's the non-negativity constraints or condition. So given all this information, we can create our model. We can develop a model in Excel. So let's do so. So let's call this ABC company. And this company will produce two products, which are X and Y. And so quantity. And at this time, we haven't made decisions of how much of X should be produced and how much of Y should be produced. And so we can just put any value there. We can go with zeros for now because this will be our changing variable cells. And so let me call this. So this one will be changing, and we can put any values for now. We can put 1 or zeros. We can put the per unit profit. So the per unit profit of X is 182. Let me write here 182. And the per unit profit of Y is 139. And then let's see the inputs. And so we have labor hours, we have chipsets, and then we have electronics component. So in this equation here, we can see that we will require 6 hours of labor to produce a unit of X, and also 9 labor hours to produce a unit of Y. So we are going to put them here, 6 and 9. So for the chipsets, as we said, we will require 1 and 1. So here we have 1 and 1. And for the electronic components, we are utilizing 15 of X, 15 for X, and also we will utilize 10 of the electronic components to produce a unit of Y. So then we are going to see how much of these resources are used. So in this case, we are going to see how much resources will be used if we change these quantities, if we produce more of X or more of Y. So to do so, we can use the function. if we put equal sign here, we could take 6 times 1 plus 9 times a value here, which for now is 0. 6 times 1, so that means 6 times the quantity of x plus 9 times the quantity of y. And so in this case, if you enter, you will get at this moment only 6 labor hours have been used to produce a unit of x, and we are not utilizing any because we are not producing y. So if we put 0 there, it will also be 0 because we are not producing x or y, and therefore we are not utilizing any labor hours. However, we can use another function to get the same results, and so we can put equal sign and just type sum product. And so this function sum product is exactly the same as what we did. We take 6 times the quantity of x plus 9 times the quantity of y. So that's the same. So now let me select the sum product function, and all we have to do is just select the values of the labor hours for x and y, and then you can put the comma sign and select the quantities. And in this case, you can close the bracket and enter. So we'll get exactly the same as what we did. Now, we would like to copy the function for chipsets and electronics, and all this will also will focus on how much quantities of x and y that we're going to produce. And so we can copy this formula way down. However, we need to lock down these changing variables, and we can do so by putting the $sign here. So I will type the $sign and here, but actually you are not you can put the $sign if you're using Windows by clicking on F4, and if you're using Mac, you can hold down function and F4, or you can also hold down command and T. So, but make sure that you have $signs between this B4, so within this cell, and also the $sign for C4. And so you can enter, and then now you can copy the formula way down. So you can see that we are not utilizing any labor hours or chipsets or even electronics because we are not producing any unit of x or y. But let's say if we put ones, meaning that we are going to produce per unit, a unit of x and a unit of y, you can see how much of the resources we have used. So the question is, have we used all the resources? We are actually not utilizing all our resources because we have 7,000 labor hours, 1,000 chipsets, and 14,000 electronic components. So I'm going to put the constraints here. I'll put the constraints. And for the labor hours, as we have said, we have 7,000. And then we have 1,000 chipsets, and also for electronic components, we have 14,000. But now we have to focus on the limits. And we know that we are limited by 7,000, not more than this, so it should be less or equal. And that is the same for the other resources. And so we can copy the limits. Now we have this condition which is non-negativity condition. And so we are going to type here X and Y, and the limits for this will be greater or equal to 0, and that is for X, and that will also be the same for Y. However, we need to define the what is Y and what is X, and in this case we have X and Y, and all we need is that the quantities of X and Y should not be negative. They should either be 0 or greater than 0. So that means we can put equal sign and click on the quantity of X and enter, and then put equal sign and click on the quantity of Y and enter. So if you change the quantities, you can see that they will also change. You can put 10 there. You can see this also will change. Everything actually is changing because we are producing 10 of Y. So we can change. Remember, this is the changing variable, so we can put any quantity we want. But solver will define the amount of X and Y that we can produce to maximize our profit. And so we can type here profit. And so in this case, we can find our profit. We're going to put it here or anywhere, but let me put it here. So our profit will depend on how much we produce per unit, unit profit. You can see here we have 182 as the per unit profit of X. In other words, if we produce a unit of X, we are going to make a profit of 182 and 139 for Y. So it will all depend on how much we are producing. And so in this case, we could actually click here and make it times the quantities of X plus, you click this one, times the quantities of Y, and that's the answer we can get. However, we can also use the sum product function. So you can put equal sign and type sum product and just select it. And then you can select the per unit profit, put the comma sign, and then select the quantities. And so now you can close the bracket. You'll get exactly the same answer. So in this case, if you put 0 there, you can see that our profit will be 0 because we haven't produced anything for X and Y. But if you put 1 and 1, you can see that the per unit, the profit will be 182 plus 139. So when we vary this output or the quantities of X and Y, then we're going to see how much profit we're going to make. So until here, we have completed our model. So we have our model done, and the next thing to do is to use solver to be able to identify how much of X and Y we can produce by utilizing almost all our resources. And so you can click on the tools. If you're using Mac, you can click on the data first to see if we have the add-in, which is the solver. I don't have it. And because I'm using Mac, then I can go to the tools. You can see the tools on the top, and then go to Excel add-ins, and then you can select it, solver add-in, and then you can click OK. If you're using Windows, then it's a little different, and I'll show you how you can do that. So if you can go back and click on the data, you will see solver, and so you can select solver. But let me do something. Let me close this. So here we have changing variables, and also we have profit. And let me highlight this a little different. Oh, sorry, I'll use another color. Let me use this color. So this profit is set objective, because our objective is to maximize this profit. And so by using solver, we are going to identify this as our set objective, and also we are going to vary these quantities. And so these are the changing variables, and we have constraints and these limits. So let me go back to solver. You can click on the data and then select solver. And so in this case, we have to input the set objective. And so the set objective will be this one here. And we are supposed to maximize. We are maximizing profit. We are not minimizing, or we are not even looking at the value. So we have the changing variable cells, and the changing variable cells will be these ones. And then that will be subject to the constraints. And so we have these constraints with these limits. So let's add. You can see that we have this sign, or the limits for the use the resources of all the inputs. And so we can actually select all this, and the condition is that they should be less or equal to their corresponding values. So here we have less or equal, and therefore we can select the constraints, but still we have the non-negativity condition. And so I'm going to add, and then this non-negativity condition should be greater or equal to 0. And so I'm going to select this too and change this to greater or equal, and then I will select the corresponding values, which are the zeros. And now we are done with the limits, and so I'm going to click OK. And you can see everything is all set. You can verify what we have in the solver. You can see our set objective, the maximizing value, the changing variable cells, and also the constraints. But make sure that you will check this to make unconstrained variables non-negative. And we are going to select the solving method or the algorithm. At this time, we are not using GRG nonlinear. We are using simplex LP. And in this case, I believe I'm all set. So I'm going to click solve. And once you click on the solve, you should get this, that the solver found a solution and all constraints and optimality conditions are satisfied. So if they are satisfied, then I can keep a solver solution. Otherwise, I could restore to the original values. So I can click OK, or I can add report, which is the answer and sensitivity analysis. And so you can click on sensitivity analysis if you want. That will be part of the answer. And So I think we are all set. We can click OK. And once you click OK, you can see that we have our solution. And let me evaluate the used resources. You can see that we have used 6,600, which is almost 7,000. We are left with 400, but we have utilized all the chipsets, and also we have utilized the electronic components, all of them. So we have exhausted these two resources, and by doing so, we will be producing 800 of X and 200 of Y. This is the best product mix. And in this case, they will provide us with this profit. So that is the maximum profit we can obtain, or we can maximize our profit to this level if we produce 800 of X1 and 200 of Y. So that's the optimum solution, and we are done with this particular problem.